Hello and welcome to Forrester High School Maths Department's National 5 Math Support Materials. My name is Mr. McDonald and I'm going to be talking you through your topics today. Today our learning intentions are to be able to find sector areas from arc lengths and vice versa to find arc lengths from sector areas. This is quite a difficult topic and this is about as hard as it's going to get in our circle topic. At the start of next week we'll be recapping circles, and then we'll be looking on to a new topic after that on Tuesday. So this might be a difficult lesson. Bear with me and give your assignment your best shot. Okay, so here's an example of the type of question we'll be looking at today. The arc length of a sector below is 5 centimeters. Okay, so we know that this distance, this curved side here, is 5 centimeters. What we need to do is find the area of the circle sector. Now you'll notice that we have a radius for the circle center, but we don't have an internal angle. That is why we need to use the arc length. Otherwise, if we had those two pieces of information, we'd have everything we needed to just use the circle the sector area formula. But we don't have everything we need, so we need to work backwards from arc length. All right, so we know about the arc length. That's in the question. We're going to use our formula AL is equal to angle over 360. Oops, that is a terrible theta. Pi d. Okay, second step, let's put in all the information we know about. So I know the arc length is 5. I don't know the internal angle, so I'm going to have to draw another dodgy theta over 360 pi. We're multiplying that by the diameter of this circle sector, which is not 4, that's from the outside to the center. Our diameter is going to be 8 centimeters. Okay, let's rearrange this. I'm going to start by multiplying both sides by 360. That'll get rid of that fraction that we don't really want to have to manipulate any further than we do here. So 5 lots of 360 is equal to theta times by 8 pi. And then divide by 8 pi on both sides. And we get that theta on its own is equal to 5 lots of 360. Again, if you want to calculate these things as you go, so you're dealing with whole numbers rather than sums, you can do that, that's not a problem. Divided by 8 pi, and that gives us a final answer of 71.62 degrees. I really shouldn't have said final answer of though, because that's not the final answer. That is the answer for our internal angle. We know now that this is 71.62 degrees. Forgive me for not getting that in the circle sector. Okay, so now what we're going to do is we're going to use that, and we're going to use our 4 centimeter radius to find the sector area. Okay, so once we've got our arc length worked backwards to an internal angle, what we can do is we can take a new space, I'm going to change color, and I'm going to use the sector area formula with what we know now to get my area of my sector. So theta over 360 pi r squared. Put in the information you know, so sector area is equal to 71.62, that's what we've just found, divided by 360, times that by pi, and times that by my radius, which is 4 squared. You get a final answer of sector area is equal to 10 centimeters squared. Lovely, that worked out rather nicely. And that's correct for 2 decimal places. And that's our final answer. Right, here's one more example. This time we're finding the arc length from the sector area. So we've been told that the sector area of this circle sector is 166 meters squared. We've been asked to find the arc length. We've been given the internal angle, but as you can see, we don't have a value for the radius or the diameter of this circle. So we have to find that first. We're going to use the sector area formula because we've been given area of sector as our initial piece of information. So sector area is angle over 360 pi r squared. Putting in the information we know, we've got 166 is our sector area, 235 is the internal angle, we want to figure out what the radius is here. So usual first step, we're dividing by 360 on the right hand side, so I'm going to multiply both sides of the equations by 360 in order to undo that. So we get 166 times 360. Again, you could figure that out as a normal number. I'm just going to keep it as a sum, stick it all into my calculator at the same time. That way there's less calculations where I could make a small mistake. That's equal to 235 pi r squared. I'm going to divide both sides by 235 pi. I'm a bit shocking about wanting my variable on the left hand side, so what I'm going to do is I'm going to flip this equation around and I'll get r squared is equal to 166 times 360 all divided by 235 pi. And that means that the radius is equal to the square root of all of that. Oops. This ring is getting a little bit small and difficult to work with. And I should stay consistent. I've square rooted this side and square rooted this side. The blue stuff, remember, is my thought process. You don't have to write that down as you work along, but it might be helpful to some people just to keep them focused on what they're doing. And the final answer to that is that my radius is 9 meters to 2 decimal places. Okay, so now that I've got my radius, I want to go back and actually answer the question. I've been told to find the arc length of this circle sector. So I'm going to take a new space. I'm going to write down my arc length formula. Arc length is equal to angle over 360 pi d. Arc length is equal to 235 over 360 pi times by my diameter. My radius is 9, so my diameter is 18. My final answer, arc length, is equal to 36.91 meters. Okay, so with any of these questions, we're starting with one formula, either arc length or sector area. We're working it through to find a missing detail. And then we're putting that missing detail into the other formula to find either the arc length or the sector area. Right, well done for getting through this video. It was a quick one today, but very, very complicated topic in terms of National 5 Maths. Remember, if you want to get a hold of me, you can get a hold of me through Show My Homework or email if you want to ask questions. I am more than confident that you can all do this if you've watched this video and you are motivated enough to keep going through this exercise. And remember to upload any response that you have on Teams through the class notebook personal jotter. Well done on getting through this video, and thank you very much for your time and patience, NatFab.